Because you asked, parabolas. Parabolas. A quadratic function is a polynomial function of degree 2. That means that the largest exponent attached to a variable is 2. A parabola is the graph of a quadratic function. Down here we have an example of a quadratic function, y equals x squared plus 8x plus 15. Let's take a look at a quadratic function first. Y equals x squared is the simplest function. What this means is that this is a graph. The parabola is the graph of a quadratic function. So this is a graph where the input x is going to get squared when you get the output y. So this means that for every value of x, it is going to increase not at a constant rate, but at a much larger rate than that, right? An x value of 3 gets squared to become 9, if I can put my point there. But, you know, you can see as you get larger and larger for values of x, you're going to get a much bigger value of y, right? 6 will become 36, and so on and so forth. So once x even gets to 10, now your y values are going to be up in the hundreds and then quickly in the thousands, okay? And because negative numbers raised to the second power become positive, that's why we see on the left-hand side where these x values are negative, we see the y values have the same positive as the other side of the x-axis, right? So a negative 2 to the second power is going to become 4, just like 2 to the second power is equal to 4, right? And we're going to see this kind of symmetry on a parabola. Now, a couple of things. Let's take a look at a saved one that I have here. This parabola I saved, this is a different parabola from y equals x squared because it gets moved around a little bit. But down here, a point of distinction is called the vertex. That's the very bottom of the graph, right? And if that x squared is a negative number, then it will get flipped around. Right, points that are crossing the x-axis, that is, let's say, negative 5, 0. Right there, and that is going to be also negative 3, 0. Those are called x-intercepts. That's where the point where the graph crosses the x-axis. The vertex that I was talking about before is going to be down. Ooh, not at positive 1. It's going to be down at negative 4, negative 1. All right, that is because the x squared is a positive value, has a positive coefficient. That means at the very bottom of this graph. Up here at, let's put that as an ordered pair, 0, 15. That's the point where the graph crosses the y-axis. That is called the y-intercept. Right, so just like regular lines, we're going to have x-intercepts and y-intercepts, but a straight line doesn't have a vertex like a parabola does. So to find the x-intercept, and a parabola generally has 2. It's possible it can have only 1, but you should expect to have 2 x-intercepts on every parabola. It could have 0 also, it depends. But we're going to take this quadratic function, x squared plus 8x plus 15, and we're going to set it equal to 0 and solve this equation. We can solve this equation by using the quadratic formula. Completing the square will also work. This one, though, is factorable. So that means factoring is going to be the fastest way to solve this quadratic, right? 1 multiplies to 15, adds up to 8. That's going to be the factors of 3 and 5. And because x squared is a monic, means that it has a coefficient of 1, we can start each parentheses with x and x. So that means x plus 3 equals 0, x plus 5 equals 0. The zero product rule means x plus 3 times x plus 5 equals 0, means x plus 3 must equal 0. And if we add 3 to both sides, we're going to get x equals negative 3. Sorry, subtract 3. We're going to get x equals negative 3, right? But the zero product rule also states that the other factor has to equal 0. So one of these has to be true, one or the other. So we get answers of x equals negative 3, x equals negative 5. But your x-intercept is an ordered pair, right? 2 separate ordered pairs, not one ordered pair of negative 3, negative 5. Right, 2 separate ordered pairs, a negative 3, 0, negative 5, 0. An x-intercept is always going to have 0 at the y-coordinate. So let's find the y-intercept of this graph. I spelled that wrong. Intercept. So here's what we're going to do. We're going to take what's called this function, right? We're going back to this function. We're going to evaluate, not solve an equation, but called y of 0. And that's what this notation means. It doesn't mean y times 0 or anything like that. Right? That means we're going to take this x squared plus 8x plus 15 function, and we're going to plug in a number for x. And that number is going to be whatever's in the parentheses over here. In this case, 0. So when you find a y-intercept, you are always plugging in 0 for x and then evaluating. That's 0 plus 15, which is equal to 15. And once again, a y-intercept, just like an x-intercept, is an ordered pair. The difference is a y-intercept always has 0 for the x-coordinate and whatever number you solved for as the y-coordinate. So 0, 15. This confirms what we saw in the graph. So let's take this function, because I ran out of paper. Let's find the vertex over here on this page over here, right? So we're looking at y equals x squared plus 8x plus 15 once again. And the vertex of the parabola, which again is the turning point of the parabola. There's a formula called negative b over 2a. A is equal to 1, that's the coefficient of x squared. B is equal to 8, and that is the coefficient of x. So if x equals negative b over 2a is our formula, that means x is equal to negative 1, nope, not 1, negative 8 over 2 times 1, which can evaluate to negative 8 over 2, which can evaluate to a negative 4. So since we're finding the vertex, that means our vertex is an ordered pair with a x-coordinate of negative 4. Right? So this formula tells you the x-coordinate, does not tell you the y-coordinate. We're going to find the y-coordinate by evaluating, just like we did for the x-intercept. But instead of plugging in 0, we're going to plug in our value of x that we calculated previously. So we're going to plug in negative 4. That means x squared is going to say instead negative 4 squared. That means plus 8 times x is going to say plus 8 times negative 4. And that plus 15 doesn't have an x attached to it, which means it's going to stay the same. So let's evaluate this. Negative 4 to the second power is equal to a plus 16 minus 32 plus 15, right? We did exponents, and then we did this round of multiplication, kind of at the same time. Add these together, and this equals negative 1. So that means our vertex is negative 4, comma, negative 1, right? This over here was not necessary to write down. I was just writing that for display purposes. But we're taking this as our x-coordinate, we're taking this as our y-coordinate, and putting it together to calculate the vertex of a parabola. Let's do another example. Y equals 2x squared minus 16x plus 24. And we'll solve for the same things. First, the x-intercept, which is going to be 2x squared minus 16x plus 24 equals 0. It might look a little more difficult because of that 2 in front of x squared. So you can use factoring by grouping, but the first thing is take a look at these three numbers. They are all divisible by 2, which means we can factor out a 2 as a greatest common factor. And inside the parentheses here, x squared minus 8x plus 12. This is a factorable quadratic, x squared minus 8x. So we start with x and x because, again, it's a monic, a equals 1 in there. What multiplies to 12 adds up to a negative 8. That's going to be negative 2 and negative 6. Right, remember, there's a 2 in front of here, so that has to remain. So we get 2 times x minus 2 times x minus 6 equals 0. And now we can set these three factors equal to 0 using the zero product rule. Now 2 equals 0 is not an equation, so this does not result in anything. But the other two, we get x equals 2, add 6, and we get x equals 6. And once again, since this is an x-intercept, this x equals 2 represents the ordered pair of 2, 0. And x equals 6 represents the ordered pair of 6, 0. These are our two x-intercepts. So the y-intercept. Ooh, forgot to change it back. The y-intercept is going to be done the same way. We're taking y, our 2x squared minus 16x plus 24, and evaluating it with 0 plugged in for x. So 2 times 0 squared minus 16 times 0 plus 24. All right, anything times 0 is 0, so 0 minus 0 plus 24 is equal to 24. And that means we're going to get a y-intercept of 0, 24. Notice that a y-intercept has an x-coordinate of 0, and an x-intercept has y-coordinates of 0. All right, it's going to work out that way. So once again, we'll move on to the next page. Let's copy this over. And then we'll find the vertex of this parabola. We need a little more space than we had down there. I don't want to cram it up. So the first thing on finding the vertex is to use our x equals negative b over 2a formula. All right, so let's identify the coefficient of x squared to be 2, that's a. The coefficient of x is b, that's going to be a negative 16. Right, the negative signs carry through when you're identifying a and b. So notice that when we plug in negative 16, we're going to have one negative here from the formula and a second negative from b being a negative number. This is going to make a positive 16 up top, right? And the bottom is not 2a, it's 2 times 2 because a is equal to 2. So that's going to be 16 over 4, which divides out to 4. And once again, this is not the entire vertex, this is just half of it. So if we take our y function and take y of 4, that means we're going to take this function 2x squared, means 2 times 4 squared, minus 16x means minus 16 times 4, plus 24. So that's going to be 2 times 16, taking exponents first by following order of operations, PEMDAS. Exponents come first, that's how 4 squared becomes 16. Now we can multiply 32 minus 64 plus 24, and then we can add these all together. 32 minus 64 plus 24 equals negative 8. So bringing it all together and presenting our answer as an ordered pair, we get a vertex here of 4, negative 8. So let's go back to Desmos here for a minute. Let's clear all this out. And let's look at our roots, or our x-intercepts that we found. Those points were 6, 0, and also 2, 0. So located right at the black and the red point right there. We found a y-intercept that was pretty high up. It was at 0, 24. All right, so that's, if I zoom out a little bit, you'll see that point all the way up top over there. And then we found a vertex located at 4, -8, which is going to be down there at that, looks like green. So we know that this is a parabola, so we know that it has that kind of U shape. We know that it crosses the y-intercept up at 0, 24, comes down to cross the x-axis at 2, 0, comes down to the ordered pair of 4, -8, and then turns back up, goes through 6, 0, and then all the way back up, right? So these 4 points are points of distinction. Let's type in our function. Y equals 2x squared minus 16x. Let's see, so you can see it forming here. Oop. Let's finish it off. Plus 24. And then we see it kind of snap into place there, crossing those points that we found. All right, so we should be able to draw a rough sketch of a parabola based on these 4 points, but we should also definitely be able to identify a correct parabola based on these 4 points. All right, thank you.